Hi, I'm Robert Crowe. We've covered a lot of ground, from the fundamentals of JAX to building, training, and scaling models with the JAX AI Stack. In this final section, we'll bring it all together, summarizing the key strengths and reinforcing why this is such a powerful platform for your demanding machine learning challenges. Let's start with the why. Why should you consider JAX? It boils down to these core strengths. First, as we saw in the benchmarks, the performance is exceptional. This isn't a minor improvement. It's a fundamental shift in speed, thanks to the XLA compiler. Second, this performance scales. JAX is the engine behind Google's largest models for a reason. It's built to run on massive hardware with near-perfect efficiency. This power comes from its flexibility, rooted in composable transformations. And finally, the code you write is incredibly portable, running seamlessly across different hardware, a major advantage proven by studies and real-world use. The power of JAX comes from its foundation. At its core are the composable function transformations, JIT, GRAD, and VMAP, and others. Instead of methods on an object, these are transformations you apply to functions. This is a key mental shift from PyTorch. This functional approach, combined with immutability, makes your code more predictable and reproducible. All of this is supercharged by the XLA compiler, which does the heavy lifting of optimizing your code for incredible speed. So how do you build on this powerful but functional foundation? That's where Flax NNX comes in. It's your bridge to the world of neural networks. It provides a familiar, Pythonic, object-oriented API that feels very much like torch.nn module. You build models with classes and attributes, but crucially, NNX is designed to work seamlessly with JAX. This is now more true than ever because NNX modules are now native JAX PyTrees. This means that the model object itself is a data structure that JAX's core transformations understand directly. NNX's wrappers, like NNX JIT, still provide convenience, but this deep integration is what truly bridges the object-oriented style with JAX's functional power, making models easier to build, inspect, and debug. JAX and Flax NNX don't exist in a vacuum. They're part of the JAX AI Stack, a complete and modular toolkit for the entire machine learning workflow. For data, you have Grain, designed to prevent I/O from becoming your bottleneck. For optimizers, OptX's composable design gives you fine-grained control. A great example of its functional style is how it's used in the latest NNX. The optimizer update is an explicit function call, optimizer.update, giving it the gradients and a WRT parameter, making the data flow clear. For checkpointing, Orbex is built for the massive sharded models you'll be training. And to ensure everything works correctly, Checks provides the assertions and testing utilities you need. Together, they provide a robust solution for every stage of development. Adopting JAX does require a few mental shifts, especially when coming from PyTorch. When you're working directly in JAX core, one difference is moving from an imperative style to a more functional one, where you transform data rather than changing it in place. And in most cases, state is handled explicitly. Parallelism is also different. Instead of wrapping your model in a DDP or FSDP object, you annotate your data and parameters to tell the compiler how to distribute them. Finally, debugging inside a JIT-compiled world requires new tools. And as we've seen, JAX provides what you need to be effective. Embracing this new paradigm has a significant payoff. Keeping up with the state of the art usually requires learning new tools and frameworks. With the JAX AI Stack, you gain access to state-of-the-art performance that lets you push the boundaries of what's possible. You can scale your work to a level that is difficult to achieve in other frameworks, with near linear efficiency. You get the flexibility to implement novel ideas without being constrained by a rigid API. And ultimately, you end up with a workflow that is more robust, reproducible, and ready for the most complex challenges in AI. So where do you go from here? We recommend starting with the official JAX AI Stack, as it packages these libraries together. Start thinking in terms of transformations. How can JIT speed things up? How can VMAP simplify your batch operation? Lean on the ecosystem. These libraries are designed to solve common problems for you. Most importantly, start building. The hands-on experience of porting a project is the fastest way to make these concepts click. Just as other developers have, you'll quickly appreciate the power and elegance of the JAX AI Stack. You can learn more about JAX and the entire JAX AI Stack with these coding exercises, quick reference docs, and slides. To watch the whole Learning JAX series, check out our playlist on YouTube. There's a growing community on Discord for JAX. Here's an invite link. And here are links to the docs for JAX, Flax, and the JAX AI Stack. This is the end of this series of videos on Learning JAX. I hope you've enjoyed it, and I hope it's been useful in your journey towards using the JAX AI Stack for AI development. Thanks, and happy JAXing!